Hi, Assalamualaikum. My name is Almi Fahim bin SHAMSUL KAMAL. I am from 2BEY Section 1. I would like to share my presentation about RLC series circuit in resonance state. And this is my group mate name. FAIZUL IMRAN bin SULAIMAN, Muhammad ZULHAZIQ bin Norman, and one Muhammad SYAMIL bin one MUSA. Okay, what is resonance? Resonance is electrical resonance occurs in an electric circuit at a particular resonant frequency when the impedance or admittance of circuit element cancel each other. In some circuit, this happens when the impedance between the input and output of the circuit is almost zero and the transfer function is close to 1. What is resonant curve? Okay, resonant curve is current varies inversely with the variation in impedance and therefore it is maximum at resonant frequency when impedance is minimum and decrease with the variation in frequency on both sides of the resonant frequency. The curve drawn between circuit current and the frequency of the applied voltage is called the resonant curve, and its shape depends upon the value of circuit resistance. As shown in the figure, for smaller value of R, the resonant curve is sharply peaked, but for larger value of R, the curve will be lower. Series circuit current at resonance. This is the waveform. The frequency response curve of a series resonance circuit shows that the magnitude of the current is a function of frequency, and plotting this onto a graph show us that the response start at near to zero, reach maximum value at the resonance frequency when I max sama dengan IR, and then drops again to nearly zero as F become infinite. The result of this that the magnitude of the voltage across the inductor L and the capacitor C can become many times larger than the supply voltage, even at resonance. But as they are equal and at opposition, they cancel each other out.
So for the formula series resonance, first inductive reactance XL equal 2 pi FL equal omega L. So for the capacitive reactance, XC equals to 1 over 2 pi FC equals 1 over omega C. So when XL bigger than XC, the circuit is inductive. When XC bigger than XL, the circuit is capacitive. So for the total circuit reactance, XT equals to XL minus XC or XC minus XL. So for the total circuit impedance, Z equals square root R squared plus X squared total equals to R plus J X. So for the bandwidth of series RLC circuit, as you can see, this is a diagram for bandwidth of series resonance circuit. So if we want to get FR for bandwidth, we can get a center from F1 and F2 from frequency and current, or Imax. So the relationship between resonance bandwidth, selectivity and quality factor for resonance circuit being defined as first resonance frequency Fr. So for Fr, the formula is XL equals to XC. So omega RL minus 1 over omega RC equals to 0. Omega squared equals to 1 over LC. and WR equals to 1 over square root LC. So for the current I at omega R, ZT equals to minutes and IS equals to max. So for the I max equals to V max over Z equals to V max over square root R squared plus XL minus XC squared equals to V max over square root R squared plus omega RL minus 1 over omega RC squared. So for the number 3, lower cut off frequency FL at half power, PM over 2, and next I equals to IM over square root 2 equals to 0.707 for IM. So for the Z equals to square root 2R, X equals to negative R for capacitive. So omega L equals to minus R, negative R over 2L plus square root R equals R over 2L square plus 1 over LC. So next is number 4, upper cut of frequency FH at half power, PM over 2, I equals to IM over square root 2 equals to 0.01 for IM, Z equals to square root 2R, X equals to positive R for inductive, omega H equals to positive R over 2L plus square root R over 2L squared plus 1 over LC. So for the number 5, bandwidth BW equals to FR over Q, FH minus FL, R over L, which is radians, or R over 2 pi L for Hertz. So for the last, quality factor Q equals to omega RL over R equals to XL over R equals to 1 over omega RCR equals to XC over R equals to 1 over R square root LC.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Shamim Piwan Mose. So today I would like to show you about how to get resonant result from the series RLC circuit using multi-SIP. Okay, for the first step, I would like to do is to construct simple series circuit. Okay, this is our simple series circuit. Here we have AC voltage, which is we use voltage 1 volt, and for the frequency we use 60 Hertz. So for the next we have here resistor. So resistance value we set the 30 ohms, and for the next we have the inductor. Inductance value we set 40 milli, and for the last we have capacitor. Capacitance value we set 0.2 micro. So we need to run the series RLC circuit. So we need to set up AC sweep. First, start frequency we set a 1 Hz, and stop frequency we set 50 kilohertz. Switch type, we choose decade, and number of point per decade, we set 2000. Vertical scale, we choose linear. For the output, we choose V3. So we need to run our simple series RLC circuit. Okay, here is the output for resonance. This circuit, what I know the graph of the top we call bandwidth. So for the bottom of graph is phase different. This is this series resonance circuit is about 90 degrees lead. So that's all from me. Thank you.
Using the same circuit, we use multi-sim software to simulate the circuit to compare the result. After the simulation, we got inductor impedance XL equal to 15.08, capacitor impedance XC equal to 13262.91. Next, frequency we got 9779.41 Hz. And the last one is current, which is 30 milliampere. For conclusion, the resonance of the series RCL circuit occur when the inductive and capacitive reactance are equal in magnitude but cancel each other because they are 180 degree apart in phase. The sharp minimum in impedance, which occur in is useful in tuning applications. Thank you.